Okay, hello. So in this video, we're going to talk about adding and subtracting rational expressions. So go ahead and title your notes, this title here. And we are going to highlight some of these vocabulary words in the video. So listen to those as I use them, and also make sure to use those in your summary at the end of the video. Okay, so the first thing that we're going to talk about here is adding and subtracting rational. Here it should say expressions, with the same denominator. Okay, so right here, all this means is that we can go ahead and add and subtract rational expressions just like we can add and subtract rational numbers. Okay, the only key thing is they have to have the same denominator. Okay, so that's important. So right here, we look to see, do they have the same denominator? Yep, so we can go ahead and add those. So 7 plus 2 is 9, so our answer is 9/5. And we can do the same thing when we're subtracting irrational numbers as well. So we have 3/4 minus 1/4, and we know that'll become 2/4, which will then become 1/2. Okay. Now here's an example about rational expressions. So they both have the same denominator. So I can go ahead and write this as 5x. And then I can go ahead and add 4 plus 1 here, add the numerators, and so I get 5 over 5x, right? But over here I notice that I can simplify this further. So I'm going to go ahead, and this is like 5 times 1 and 5 times x. So then I can apply the property of 1 here. 5 over 5 would equal 1, and simplify this as 1 over x. Okay, and then here, same thing. They both have the same denominator, 5x. This time it's the same problem, but just subtraction. So I can go ahead and write this all under 5x and do 4 minus 1, and that will become 3 over 5x, right? And they don't have anything I can further simplify. Therefore, that is my answer. Cool. Easy peasy. Next thing, right here, adding and subtracting rational numbers or expressions. Should say expressions with unlike denominators. All right, so I have a bunch of text here. These are the key points that you want to have in your notebook. But the most important thing that I want you to walk away from when they're unlike denominators, we need to find a common denominator. All right, so you need to find a common denominator. And here, these are just two things that basically mean the same thing. So here, when adding rational numbers, we have to find a common, it should say common multiple. Yes, we can say that. To find a common multiple for the two denominators and write each rational number as an equivalent rational number with the new common denominator. Then we can add the numerators together. Okay, you're just like, what is all that? Cool. So all this really means is right here. So here are key steps. So it says completely factor both denominators. I'm going to explain what that looks like when we get to a problem like that. And then find a least common denominator. Now this right here, so when you're talking about your key steps, this is probably the most key thing. So when you're finding the least common denominator, you need to identify all unique factors with the greatest exponent. With the greatest exponent for each factor. Okay, and then after we do that, we will rewrite each expression as an equivalent rational expression. I'll explain that in a moment. And then we'll apply the same rules of adding and subtracting by the same denominator by combining numerators. And then we will simplify. Okay, so that's kind of like our key, these are our key points here to ground us as we're working through these problems. All right, so first example, okay, so it says completely factor both denominators. So these are not factorable They're already fully factored, so we can go ahead and skip that step. So right here, we're going to go to step 2, finding least common denominator. So we need to identify all unique factors. Well, I know my factors here for a squared and b squared are my unique factors are a and b, right? But I need to pick the ones with the greatest exponent to find the least common denominator. So I look at a squared has the highest one, so therefore a squared is what I'm going to consider as part of my common denominator. And then I see b squared has the second highest exponent. So this right here is my least common denominator. Great. Okay, so then I'm going to rearrange all of these to have a squared, b squared as their common denominator, right? So I'm going to rewrite my problem. And so I know this is my goal. I want a squared, b squared as my common denominator. So then right here, I look at my original problem. I look to see what term do I need to multiply this by in order for me to get this common denominator. So all I need missing is changing this b to b squared. So I'm going to multiply the denominator times b and then also the numerator times b. So therefore my new numerator is going to be ab times b. And then over here I check to see, okay, I want a squared, b squared. Well, I need to multiply this times a and on the bottom to give me a squared, and then a on the top as well, because whatever I do to the bottom, I do to the top. So I have a plus b times a. Okay, so this up here, now I can rewrite my numerator all under the same common denominator, which is a squared, b squared. So my new numerator is going to be a minus b times b plus a plus b times a. So in your notes, you can go ahead and put this as your scratch work so we can make sure that our flow here is clean. So our scratch work is going to look like this, so that way I can show this to my partner. If they are like looking at my work, they can see exactly what I'm doing. So right here, I'm going to distribute the b, and I will get, let's see, ab minus b squared. And then same thing over here, I'll distribute the a, and I will get a squared plus BA, and I'm adding these. So I check to see if I can combine like terms, and I can. This will become 2ab, and these are individual, so I have minus b squared plus a squared, and then I can rearrange them. Okay, and so that's my new numerator. So therefore, I will have this written as a squared plus 2ab minus b squared, all under my common denominator, a squared plus b squared, and that is my answer. I checked to see if I can simplify, but I know from here I can't, so that is it for that. All right, moving on to example 2. So I'm still following the same steps. So completely factor both denominator and numerator. So these I can't factor at all. So I need to do step 2, which again says to find the common denominator by listing all the unique factors. So I have a as one of my denominators and a minus 5. Okay, so these are itself that are the its own factors. So in this case, both of these are unique factors. So my LCD, or least common denominator, is both of these when I multiplied together. So it's a times a minus 5. Okay, so now that I've identified my least common denominator, I can go ahead and rewrite this to be equivalent values. So here I have this, I want this to be a times a minus 5, and the same thing here, a times a minus 5. So then I look to check, okay, so I need to get, my goal is to get my denominator to equal to this, so therefore I need to multiply this times a minus 5, and then here times a minus 5. So I'll get 2 times a minus 5 on my left side, and then here I'm missing the a, so I'm going to multiply times a, and I'll get 3a on the top, right? So then I go ahead and rewrite this all under the same common denominator, and I will get, 2 times a minus 5 minus 3a, and then here I'll show my scratch work, so I can show my work here. So I have 2 times a minus 5 minus 3a. Distribute the 2, I'll get 2a minus 5 minus 3a. I can see here, this is, I can combine like terms, and I'll get minus a minus 5. So my new numerator is negative a minus 5, all under the common denominator of a minus 5. And you could also factor out this negative. So if you wanted to do this and say this was a plus 5, that is a valid answer as well. These are both similar, but there's no need, because the only way you would want to check to see if you can factor out that negative is to see if you can apply the property of 1 here, but obviously the signs are different, so we are not able to. So this is our answer, or this one. All right, example 3, a couple more examples. Example 3 is a little more complex, but it is no big deal. So we have to find the least common denominator, right? So this is the one where you have to follow step 1 by factoring, okay? So this was b squared minus 2bc plus c squared. We need to actually factor that, so before we find the least common denominator. So b squared minus 2bc plus c squared. You can do the box method here, and I know this will become b squared, and this is c squared. So therefore, this is b, and this is b, this is b. And here is c, and then we have b times b gives me b squared, and I want this to equal negative 2bc. So these must both be negative bc. So therefore, this should be minus c and minus c. And these are my two factors. So this can be written as b minus c times b minus c. Or it can be further down as b minus c squared, right? So all of this gets factored out to b minus c squared. So going back to our rule about listing all the unique factors, so I have b minus c from this rational expression, and then b minus c squared from this part of my rational expression. So which one has the highest exponent? They both are the same binomial, so then you have to see, okay, which one has the highest exponent, and it's this one here. So that's our least common denominator. So then this becomes, we want this to be b minus c squared, and then b minus c squared. Now, this is equivalent to this, so we don't have to change anything. That's already has the highest or the least common denominator. So then here I want this to be b minus c squared, or b minus c squared. So in this case, I would need to multiply this times another b minus c, and then whatever I do to the bottom, I do to the top. So then this becomes b times b minus c, right? So now my new numerator is equal to b minus c squared, and I have b squared minus, and just to keep my colors consistent, b minus c. Okay, then you can do your scratch work, and I have b squared minus b times b minus c. I can distribute the b, and I get b squared minus or plus bc. And then I'll notice that b squared minus b squared will give me 0. So then I'm just left over with bc. So then my final answer is going to be bc over b minus c squared. Okay. Example 4, we are going to continue that in a moment. So I may pause the video for right now. Yes. Okay. Pause. All right. So this one is our last example. I just want to make sure that we get this in. So for this one, this is going to be, this one's very unique because we need to factor out this first. Okay, so that follows the step that I have up here. So it says to completely factor both denominators. So when I'm going to go ahead and factor this. This is x squared minus 1. So that's x. These are a difference of squares, so I get x plus 1 and x minus 1. And then here I have x squared plus x minus 2. And you can do box method for that, or you can do it in your head, which is what I'm doing. And so then this will become plus 2 and minus 1, right? So these are the factors of our denominators. So you can go ahead and list them here for the least common denominator. So we have x plus 1 and then x minus 1 as one set, and then x minus 1 and then x plus 2. Now, to find the least common denominator, we need to identify all the unique factors, and then any of those that have the highest exponent will include that, okay? So what I mean by that is like, well, I only have x plus 1, so therefore x plus 1 will be part of my least common denominator. It's one of the unique ones. And then I have x minus 1 twice, but there's not one with like squared, for instance, so therefore I just have to write this as only one time, so it's x minus 1. And then here I just have 1x plus 2, so it's 1x plus 2. Okay, so that is my LCD for this problem. Okay, so then here I can go ahead and rewrite this with the new common denominator. So my goal is to have x plus 1 times x minus 1 times x plus 2, and then minus the same thing, so x plus 1 times x minus 1 times x plus 2, right? And so then from there, I check to see my originals, like, okay, I have an x plus 1, I have an x minus 1, I don't have an x plus 2, therefore I'm going to multiply the top and bottom for my first one, this is going to get really messy, by x plus 2, right? So I'll get x plus 2 here, and then x plus 2 here. Right, so my new numerator for this one would be x times x plus 2. And then on the right side, let's see, I don't have an x plus 1, but I do have an x minus 1 binomial, an x plus 2 binomial. Therefore, in order for me to get the same denominator, I need to multiply this side by x plus 1 and x plus 1. So my new numerator up here is going to be 2x times x plus 1, right? And then I'm going to go ahead and write these all under the same essentially fraction bar. So then here this will become x times x plus 1 or 2, and then minus 2x times x plus 1. And go ahead and do the scratch work on the side. So I know this will be, I'm just going to rewrite it. I can go ahead and distribute. I get x squared plus 2x, distribute. I get negative 2x squared and then a negative 2x. Combine any like terms. These will cancel. X squared minus 2x gives me a negative x squared. So therefore, my final answer is equal to whatever my common denominator is with my new numerator, which is negative x squared. And that is it. And we're done.